with Rolls Theorem, you have a specific case or special case of the mean value theorem where f of a is equal to f of b. So what happens, we want to ask ourselves what happens when f of a is equal to f of b. If you find the slope of between 2 points of the secant line in which the two y values are equal to each other, because that's what f of a equals f of b means, then essentially you have 0 on top of your fraction. And so our guarantee is that f prime of c is actually equal to 0. So let's pick out two values that we see on the graph as a representation. So if you look at f of -2 on the graph being here and f of 2 being here, draw a line that represents the secant line. If we ask ourselves what is the slope of that secant line, just make that point bigger here, then we would say the slope of this secant line is equal to 0. So if we remember mean value theorem and plug in 0 for the side that is the slope of the secant line, then we get the Rolls theorem. Okay, and it's highlighted here as it's a special case of the mean value theorem, where instead of f of a and f of b being at different values like we have here with the mean value theorem, we have the Rolls theorem guarantees that the derivative is equal to 0, or the slope of the tangent line is 0 at some point between a and b. So let's take a look at our first example, and we can actually write in the Rolls theorem section, our Rolls theorem would say that f prime of c is equal to 0, and that is the slope of the secant line. This is the slope of the tangent line. So does Rolls' theorem apply for f of x equals x to the fourth minus x squared on the closed interval between -2 and 2? So first, with both MVT and Rolls' theorem, we want to make sure, is that function continuous? And every polynomial function is continuous. So we know that mean value theorem applies. In order for it to also apply, it must be differentiable, and all polynomial functions are differentiable by power rule. The next thing is, for Rolls' theorem to apply, we need to make sure that f of -2 must be equal to f of 2. So if we plug -2 in to our equation, does it equal 2 plugged in? And we get 16 minus 4 equals 16 minus 4. So therefore, Rolls' theorem would apply. And it just asked us, does Rolls' theorem apply? And so your check is for this. So check for continuity and differentiability. If it's a free response, I would mention both. And then check that f of a is equal to f of b. And then we can apply Rolls' theorem. So for this one, if we were to apply Rolls' theorem, if they had asked what value of c guarantees this, we would say the slope, again, the slope of the tangent line must be equal to the slope of the secant line, with this being the special case in which the slope of the secant line is 0. And we would say that the slope of the tangent line is the derivative. So 3x cubed minus 2x, 4x cubed, thought something seemed off with that, power rule, 4x cubed minus 2x, and then we can factor out a 2 and an x to get x squared minus 1 equals 0. When we factor out the 2x, we should have gotten 2x squared. So 4x cubed minus 2x when we double check our answers. So from here, if we set each one of those terms equal to 0, 2x equals 0, we have x equals 0, which is between -2 and 2. And then if we set 2x squared minus 1 equals 0, we get x squared equals 1 over 2, or x equals plus or minus radical 2 over 2. And we know from our many problems that we've done with trig that rad 2 over 2 does fall between -2 and 2. So there's actually 3 values in which this is satisfied. And so these are our c values or our x values between a and b. For example 2, you have the following table represents a function f of x that is differentiable everywhere. So again, we want to recall differentiability implies continuity. Does the graph have at least one horizontal tangent line? And then explain. Okay, so if it does have one horizontal tangent line, I should see the change in y over the change in x in that direction be equal to 0. And for that to be true, your change of y, we're going to look for the y values to be the same over the x values. So the slope of the secant line, we're going to look for change in y over change in x, where the change in y is equal to 0. And that does occur between the x values of 1 and 4. So yes, between 1 and 4 seconds, we have f of x actually, let's say instead of between, we should say at 1 and 4 seconds, we have f of x is equal to -2. So by Rolls theorem, since f of -2 is equal to f of 2, we are guaranteed a value c between x equals 1 and 4, in which f prime of c is equal to 0. Considering f of x is continuous. Example 3. You guys have the following represents the position of the particle in inches where t is in seconds. Note that s of t is differentiable everywhere. Again, implies continuity. And I'm going to use therefore, the therefore symbol with the dots. Clean that up a little bit. So differentiability, therefore continuous. So therefore it implies continuity. And question A is asking, what is the minimum number of times the particle is 4 inches? So now this is asking for position being 4 inches. So given that it is continuous, we can see through IVT that there's a change between 1 and 3 seconds from 3 to 5, then between 3 and 4, 5 to 3, and then between 4 and 6, 3 to 7, in which the function must pass the value of 4 in order to get from one value to the next. And so because s of t is continuous, we can apply IVT and say that s of t must be equal to 4 at least 3 times between, and then I'll list out the times between. So let's say between time 1 and 3 seconds, between time 3 and 4 seconds, and then again between 4 and 6. And then I'll just where and then we can say f of x is between, for time 1 to 3 seconds, it's between 3 and 5 seconds, and actually instead of f of x, let's say s of t, because that's what our function is actually named. S of t is between 3 and 5 seconds. And between 3 and 4 seconds, we have s of t is between 5 and 3. So I'm going to write 3 again first because this is a compound inequality, 3 and 5. And then s of t is between 7 and 3 on the interval of time for between 4 and 6. So IVT, we mentioned it's continuous, we mentioned IVT, we mentioned the domain over which it occurs, and then the change that happens on the range. So the next question is the particle ever at rest? If the particle is at rest, then we would picture that velocity, or s prime of t, is equal to 0. And that we know must occur because of Rolls Theorem and the fact that we know that this function is continuous. There is a value between, if we look here, erase that, between time t equals 1 and 4. If I were to find the slope of the secant line, I would see that the slope of the secant line has the y value of 3 minus 3 on top over 4 minus 1 on top. So therefore, the slope of the secant line is equal to 0. So in this case, we're looking to see if that occurs. And since the function is continuous and differentiable, we can apply Rolls Theorem over the interval from 1 seconds to 4 seconds, because the y value is there. F of 1 is equal to f of 4. So therefore, the derivative of s of t must be equal to 0 at some point between 1 and 4. So I mentioned Rolls Theorem, I mentioned continuity and differentiability, so I'll highlight that, and also the guarantee that f of a is equal to f of b, and then also that the derivative is equal to 0. So those are the main things you want to hit upon when asked about Rolls Theorem.